We're going to find the end behavior, okay? This one, negative 3x to the 6th power plus 4x squared minus 3x plus 6. Okay, on this one, we're doing something different. These we were evaluating. They told us what x was. On this one, we're going to answer a couple of different questions, and we're going to find the end behavior. Okay, what are the ends of the graph doing? Okay, we can tell what the ends of the graph are going to do without even putting it into y equals. Okay, first of all, we need to find what's the degree of this one. It is 6. Thanks, Titi. Right, 6. The highest degree is 6. Okay, so that's even. That's an even number. And what is the lead coefficient? Is it negative or positive? Right, it's negative 3, so it's negative. Okay, so it's an even negative. Okay, so those are the two most important things. Even though it's 6 and we haven't done 1 to the 6th power yet, we can look on here on the front and look at the even negative, and it's going to look like the even negative here. Here we've got odd positive, odd negative, even positive, even negative. Okay, these are the 4 options you can have. Since we know it's even negative, we know both ends are going to point down. Okay, this is our end behavior. It's going to have the same end behavior no matter what goes on in the middle. Okay, so on the left-hand side, it's going to go down. On the right-hand side, it's going to go down. So I'm going to just draw a little sketch of it. Okay, it's 6, so it's going to go 1, 2, 3, 4, 5, 6. Okay, on the left-hand side, it's going down. On the right-hand side, it's going down. We can write exactly what the end behavior is from our first page. Okay, and the way that you write that is the graph goes down to negative infinity as x goes to negative infinity, okay, which is the left-hand side. And that's this side. Left-hand side is x goes to negative infinity. And the right-hand side is also going down. So the graph goes down on this side too. Both of these, it's going to negative infinity. As x goes to positive infinity. That's the right-hand side. Okay, the x is left and right, you know, x left and then right. And then f of x is the graph. So it's pointing up or down. Yeah, and this one is down. But I'm just mean like on all of them, the f of x will be up and down. This will be left and right. You know, this one will always have left first and then right. Okay, so this part will always be the same. These depend on which way it's going. Okay. All right, number 7, 3 more. G of x equals 4/5 x plus 6x squared plus 3x to the 5th power minus 3x cubed minus 2. See, it looks super complicated, but we're only looking for like 1 or 2 things in it. So it's not as terrible as it looks like it is. Okay, so first, what's the highest degree? 5, right? 5, so that's an odd. Right, and the lead coefficient will be what's in front of the one with the exponent of 5. 3. Okay, that's positive. Okay, so that one would be in front. We don't even have to put it in standard form right now. Right, they didn't ask us to. We just need to know that that's what we're looking at, is this term. Okay, it's an odd positive. Okay, so again, I'm going to look back here. Odd positive is just like this one. Okay, it's positive. It's going to go like this. The left-hand side is going to be going down. The right-hand side is going to be going up. So it'll go like this.
So what type
I'm not 100% sure what the types are after quartic. I would assume quintic, but I don't know all the types. Or I don't even know if they all have names after they get that high. But the point of this is, as long as you know if it's odd or even, you can answer all the rest of the questions, even if you don't know the name of the type. I don't know. They must stop at some point. Like, I'm sure 17 doesn't have a name. But 5 kind of seems like would make sense. So, it's going to have the same end behavior as this. Okay? You can just copy it from here.
You find your degree by the highest exponent, right?
The highest exponent, yes.
Okay, but when we doing this, we don't count like 1, 2, 3, 4, 5. We just do 3.
Whatever the highest exponent is. Because it could be like on number 5. Well, like on number 5, there was only 3 terms, but it went x to the 4th power. There was no x cubed and x to the 1, but there's just not anything there because it's 0. But it's, you're not counting how many there are, no. Okay, so on this one, our end behavior,